drainage test, once we have that capillary column close to the top or almost to the top, you want to compress again. In sands that have a lot of clay, now it's lubricated with water, and you'll see a deeper plunge of separation and compaction. So now we have the top of the sand, and we're going to make another mark 2.5 centimeters or 25 millimeters above the top of the sand. That is my destination mark to start the drainage test. So in the drainage test, we slowly pour the water up till it reaches that 2.5 mark, and we start the stopwatch and wait. Initially, you'll see saturation at the top and the water starts to drop. And when you see bubbles, the water is now displacing the air bubbles between the sands as it's going downward. And it's very important in the drainage test that we have this open bottom. So the air, when it starts to drain and the water has a place to go, we're not compressing it in a closed vessel.
It's moving. You can see it moving.
Yeah. So the goal is to measure the time it takes to drop 2.5 centimeters. And we want that time for most sands to be less than 10 minutes. Some sands might be 3 or 5 minutes, but once we're into the 20, 30 minutes, we're looking at a sand that really probably has too much clay and it doesn't drain well. Then it's really not that approved for the epic profile. Not that it doesn't capillarize up, but it doesn't drain well. And when things don't drain well, it doesn't have that gas exchange occurring with the root zone. We don't have oxygen moving down. We don't have CO2 moving out of the profile. So the goal is try to find a combination of sand that is draining in less than 10-minute mark.
So we're about maybe 2 minutes now?
I didn't start.
It looks like we're at 3 minutes on this video, so
Yeah.
I think it's doing pretty well.
Yeah.
It's already halfway down.
Let me go to the timer. We're about halfway down in 3 minutes, but the first run is you want to repeat this about 3 or 4 times till you have an even time frame. The first run sometimes is faster because it was absorbed with the dry sand in the upper layer, and then it stabilizes. Yeah, stopwatch on your cell phone is a good tool. Just press the button and wait till the water line hits the top of the sand and stop and record that time on a piece of note.
Because documenting these times is
Yeah,
crucial on comparing the different sands considered for the project.
right. And I run this again 3 or 4 runs, so once the water line hits the top of the sand, I add more water to the 25 millimeter mark and time it again. So 2 or 3 runs, you should see the same time frame, and that really shows the porosity of the sand that is being measured.
But you don't add it while you're timing it. You wait till it completes.
Wait till it completes. So the second run, you start at the 2.5 above the sand and wait till it hits the sand again and make the stop and record the time.
Okay.
So you're measuring the time lapse of that 1 inch of water to drop. And this is a lot of drainage, even though it's slow. In 10 minutes, you have 1 inch. So a large rainstorm is simply going to be absorbed in 10 minutes. But consistent rainstorms in 10 minutes in a 24-hour period is 6 times 24 is a lot of water that you can move through the profile.
We're at just over 6 minutes now.
Yeah.
Almost done. So this is in real time. And I find it interesting that we don't see it in the cup yet.
It's starting to rise in the cup.
Okay.
At the next run, it'll start. After 3 or 4 runs, the cup is going to be full. And what we'll be doing then is siphoning off the top so you don't get your table wet and transfer the excess water. So the water reached the top of the sand, and now I'm adding more water to my 25 millimeter mark and push the stop on your timer and run it again till it reaches the top.
Right.
Usually by the second or third run, you'll see water bubbling up through my bridging gravel at the bottom, and before it exits the cup, just siphon it off and discard it.
So the most important part of this test is we're timing the length of time it takes to drain that 2.5 centimeters.
Right.
All right, let's time lapse that.
So as we can see in the lap 1, we had a fairly fast time, 4.56 or 5 minutes. On the second run, it was 8.4. So the water slowed down because we overcompensated with the dry sand in the beginning. So you make a third run, so you're within pretty much consistent rate. So if you can fill it again to my 25 millimeter mark and start again the lap. And now you can probably see the water is starting to rise and lapping at the bottom. So I can remove some of it. And for extensive tests, this would be the time you can get a pH paper and test the water that is coming up. Because if there are hydroxides in there, your pH might be too high. So as the water rinses the sand and wells up, that's a good time to measure the pH of the water. And this is what we do on our readings. Thank you for watching our simple drainage analysis test, and you can get more information on our websites. Thank you.